Now, with this slideshow, we're going to start talking about what we call composition of functions. Okay, so we'll talk about that by means of example and then make a generalization about it. Okay, we're going to consider two functions: a polynomial, a linear function f of x 2x plus 1, and a quadratic function x squared minus 3. Now, we're going to ask you to do the following. What is f of g of 3? Well, we know that the notation implies g of 3 is the implied plug 3 in for x into g. And then that implies take the result of that and plug it in s. So this implies evaluating function g at the value of 3, then using the resulting value to evaluate function f. Okay, so g of 3 is 3 squared minus 3, which is 9 minus 3 or 6. 6 then becomes the value of input into function f. So then with that, now evaluate function f at the value of 6. Okay, so we go back and in place of x in function g, we're going to place 6, which is going to give us 13. So the overall result, f of g of 13 would be, f of g of 3 would be 13. Try it again. Let's just say we have f of g of 1. G of 1 is 1 minus 2, 1 minus 3, which is negative 2. Negative 2 in for here is, okay, negative 4 plus 1, negative 3. You can try it yourself. We're going to do a couple more. Let's do g f of 8. Okay, g f of 8. Now notice that this is in the opposite order. We're going taking the value, plugging it into f first of 8, which is 16, 17, and then throwing that into function g, which would be 17 squared 289 minus 3. So that's what we should see. F of 8 is 17, as we said, and then g of 17 is, of course, 17 squared 289 less 3, 286. So g of f of 8, function g evaluated at f with the value of 8 is 286, okay? F of g of 12 now. F of g of 12. Well, again, g of 12 goes first. G of 12, 12 squared, 144, less 3, 141. Then 141 as the input value into f, okay, which is doubled, and then added 1, so it's 283. So in the end result, f of g of 12 is 283, okay? G of f of negative 5, g of f of negative 5. So from evaluating from the innermost, f of negative 5 is negative 10 plus 1 is negative 9, and negative 9 into g would be 81 less 3 or 78. So that's what we should find. Okay, let's go back and let you check on that. F of the innermost evaluated, and the result of that plugged into the outermost expression. Okay, the innermost being f of negative 5, resulting in negative 9. That then plugged into g for the final evaluation. Okay, all right. Now let's consider doing this again with these two functions, f and g, 3x plus 1 and gx squared. Let's determine these values, f of g of 2, f of g of negative 5, and f of g of 7. Okay. F of g of 2, again, says let's go to function g with the value of 2. 2 squared is 4, and then take 4 into function f, and 4 times 3 plus 1 is 13, okay? But I want to consider a more generalized composition. Rather than just work with numbers, let's work with the functions themselves. What if we were asked to say, what is f of g of x? Well, what that would imply is for us to replace all x's in function f, okay, with g of x. So that's what we say. This calls for replacing all x values in function f with the g of x value, which would look like this. F of x used to read 3x plus 1. It now reads 3 times g of x plus 1. But g of x is now this expression x squared, so we replace that and we get this. So now we have a generalized expression for fg of x, okay? Which we could use to value each and every one of these, okay? So in other words, instead of going into G, taking the result and feeding it into F, we could have just gone with the original value, fg of 2. We could have gone with the original value 2 right into this 3x squared plus 1, or 2 squared, 4, 12, 13. You get the same result either way. So that's what we're doing here. We're comparing and showing that you can get the same thing going to 2 steps or going 1 step, as it were. 2 steps, okay, evaluate the innermost function, g of -5 resulting in 25, plug that into the outermost function, f, resulting in 76, or alternately, okay, just going back into the general composition, 3x squared plus 1, with the input value of -5, okay, ending up with the same thing. Again, fg of 7, 2 steps, g of 7, okay, 7 squared, 49, f of 49, which would be 49 times 3 plus 1, okay, which is 148. Or, alternately, just going to the general expression for f of g of x, okay, which is 3x squared plus 1, with the value of 7 put in right into there. 7 squared, 49 times 3, 147 plus 1, 148. Okay, so what we're trying to show here is using the general composition for fg of x, which ended up giving us 3x squared plus 1, as shown in, well, it's not blue, it said blue, brown, orange, whatever color it is. Okay, so use the general composition to determine those values. I think proves to be more efficient, because if you are asked to do this 3-4 times over, let's just do it once in a very general sense, and then use that for the assessments of all the other particulars. Okay, so that's basically what we're trying to do, is be able to do a composition of function, one function in place for the other function as a new value of x. And we'll look at more of that in the next presentation. I think that should give you enough to think about for now. Okay, so